All right. I think we're
We
live,
live?
Jose.
We live? We
I
live?
think so, yeah.
You think so? Ooh, baby, we're back with another stream, with another live stream. How you feeling, Carlos? How you feeling, brother?
I
How's
feel mentally stressed, drained,
okay?
but not really drained. No, I'm not drained. I just feel mentally stressed.
Mentally stressed.
Yeah.
Okay, okay. Can I ask
But
why,
but
or is it
that
just
that's a
like
part of trying to be better each
okay?
day. You got to push
Hey,
yourself.
hey, you know, hey, brother. Don't push that much, brother. You deserve to
No,
rest a
I'm
couple here and
pushing.
there. Oh, you're pushing hard. Okay,
Yeah.
I respect that. All right, I respect that. All
Yeah.
right.
But the main word is consistency.
Consistency.
Yeah, and
Yes,
structure.
sir.
That's the main thing
I don't know if
that
you read the book Outliers. I forgot, but and it's it's a good book. I recommend it. I read like half of it because it got boring towards the middle, but
oh,
it explains how different people are successful, and it tracks how people are successful. And one of them is a 10,000 hour rule. I don't know if you've heard
ufas.
about it.
If
Where if
you
you
spend 10,000 hours, then you're a professional at the skill or something?
yes sir, yes sir. So,
No, what
it's
tell
how
me what was it? I don't know.
no, yeah, no, yeah, it's pretty much that. It says like, hey, you spend 10,000 hours and then you can consider yourself a professional, So, hey, one day, a minute, an hour, bro, you're closer to that 10,000 hour mark, you know? And,
Think
hey,
so?
bro, I think so, my guy. I think so,
All right, well, I guess we'll
Yes,
have to
sir.
see. But anyways, yeah, no, nothing much, bro, just grocery shopping,
Yes,
you
sir.
know. Um, I'm finding some new finds, some good finds. One of my issues is like I I don't make food as often as I should.
Okay, okay.
So I'm trying to make food easier to make. I'm
Okay,
trying
fair.
I'm trying to make it easier to make food.
Yeah, okay, that
Yeah.
makes sense. Okay,
So,
okay.
for example, there's these like it's so crazy to me how like I don't I hate saying it because I could literally do it myself, but
Hey.
it's like these pouches, these smoothie pouches,
Okay,
and they're packaged like it's a one big bag, and
okay.
there's individual pouches of fruit
Uh-huh.
in it, and it's just fruit. Like they don't
Oh,
add
okay.
no
Yeah, okay.
like sugars or anything or like other stuff. It's literally just frozen fruit, but it's
Uh-huh.
packaged and
Okay.
into specific portions, right? And I
Okay.
put that in the blender. I put some whole milk in it to make it like liquid, like
Yeah.
and
Yeah,
then
yeah.
yeah, that's one of my little things that I eat on
Damn.
side of my normal breakfast that I make, which is just eggs
Okay.
and bacon.
Hey, are those what do you call it? Smoothies, right? Or
Yeah, it's a
yeah.
smoothie basically.
Yeah. Are they good though? Like,
I
does it
think
taste good?
they're good, but don't imagine like a Smoothie King smoothie, like
Yeah.
a fruit smoothie from like Sonic or something. Like, don't imagine that because what they have there, they have like they put other stuff other than fruit. Does that make
Okay.
sense? And it makes
Yeah.
it more sweet. It makes it taste maybe better or whatever the case may be, right? So this is just purely just like fruit and
Damn.
milk, fruit, milk, and
Okay.
whatever. So
Damn, bro.
I like it. I
Yeah,
think
I
it
mean
tastes pretty good. But
it's also
people that are used to like those Smoothie King smoothies, like they add some more stuff. Like Smoothie King is a
yeah.
little bit better than like Sonic smoothies. Don't get me wrong, but
Mhm.
like they have like protein into it or whatever. Like
Damn.
that they have some
Okay.
other tricks up their sleeves that make it a lot better. Like I don't know, I'm not there yet. All I do is just put the fruit in the blender and put some milk, and then that's it. I call it a day.
Damn. And I mean,
Yeah,
I'm assuming since it doesn't have like any extra stuff, any like sweetener, sugar and stuff, like it's healthy, you know?
we
You're
gotta
getting
pause
like
real quick.
yeah.
Jay just said, "What fear are you guys facing?" We're facing this fear right here.
Oh.
Pass some number 3. And more specifically, there's another problem after this, which is called let me see, longest zigzag.
It's
That's another thing here. So
Ufa.
we we're actually, this is what I'm stuck on personally. So that's why I said like it's a fear because I'm scared to do these. So we're gonna face it today. And yeah. Anyways, sorry Jose. So yeah, that's
Hey,
basically it. I've been making smoothies.
hey, that's good,
Yeah.
bro. That's good,
What
you
about you?
know.
What about you?
I mean, not much, my guy. You know, I've been focused more in school. Started a little project on the side. You know, I'm
Okay.
excited for it. I'm learning new
Do you
stuff,
want
new
to talk
technologies.
about that project? Like, what do you?
Yeah, for
Maybe a
sure.
little bit.
So it's nothing too crazy. You know, it's not like a boom, like revolutionary or whatever, right? It's just pretty
Okay.
much like a uh get together planner. You know how some people like a friend group, or your partner or your girlfriend, boyfriend. Um, Sometimes you don't match because it's like, oh, I want to go over here or you want to go over there. So like they don't match, right? So
Yeah.
there you can put like all your options, right? And so you create like a little room, and everybody puts their options, 5, 10 options, right? Of activities, food, whatever they want to do, and then they get shuffled into like a little shuffle, and they all get prompted out the options. And like in a Tinder style, where you swipe left to decline, swipe right to accept,
Uh
you
huh.
can filter them, and at the end, you're gonna get a list of all the things that all of you guys agreed upon, or more majority agreed upon. And it's just a way to facilitate like planning and stuff, and dates and times and activities. But primarily did it to learn about like other stuff, like tools like socket.io, which is to create like communication
Mhm.
between the client and the server, get a little bit more of React practice into there, and just learn JavaScript as well, like a little bit more in depth in JavaScript. And but yeah, so it's not too big, but I'm just there to like project to learn,
Yeah.
project to experiment new things and see what's out there. Maybe, from there I can transition to a bigger project, but it's just something calm, something chill. And
Chill and
but yeah,
calm,
true and calm,
dude. I think
exactly.
that's actually a great idea, and I
Hey,
might
thank
need
you,
that
brother.
whenever it's done.
Hey, I got you, brother. I got you. I
You
got
said it
you. It's
works
gonna
for anything, right? You said like
it
friends and
works for
stuff. Like,
anything.
okay,
Anything, my guy. With small price, $20,
Tony
$20 per use,
per. That's crazy.
Nah, I'm
You're
kidding.
gonna
I'm
do that
making
to
it.
me,
Nah, I'm gonna give you a admin status, so you can do
admin.
whatever you
Okay,
want.
bet.
Yes, sir. I got you. I got you.
That
But
sounds
no,
cool,
it's
bro. I'm interested to see how the sockets work. So that's like creating. I think you told me earlier, like a room, if you will, and everyone's connected to that, and like
it's yeah.
or or what?
Um, Essentially, it's like you know how I know we made a Visco Pro, a project that we used a server like Flask to
Mm-hmm.
use. Yeah, so that's an HTTP server, meaning like the client can request from the backend, and the backend will respond. And after that, communication is gone, right? It's until the client initiates or sends a request to the backend that the communication starts, and then communicate, and then it disappears, the
Mm.
communication. So what socket are is to keep that communication alive, no
Ah.
matter as long as it's possible. So the client can send whatever, anytime, anything. It can send data, request data, whatever, whatever. And the client and the backend is just receiving and spitting out back.
Yeah.
So in this case, for example, let's say like a chat room, you have your server, the client sends a message to the server, and the server emits it to all the parties that are connected to the server. And now all the parties receive the message that the client side sends. So let's say you have client one, client two, client three. Client one sends hello world, and the server emits it to client two, client three, and and the client two, client three receive it, and the
Okay.
server is just like listening for anything, any activity between those three clients, and it's just emitting and
Ah, so
receiving and emitting.
that's what the socket would do is stay
Yeah, it's
on the
just gonna
server.
stay on. Yeah.
Okay.
Yes.
That's really cool.
Yeah, it is cool. It's interesting. So It's really nice and stuff, and yeah, I'm excited to explore a little bit more and see how far I can go in this project. And like I said, nothing too crazy, just something small, something to learn. But other
Something
than that,
small, something light.
yes, sir.
All right.
And
What
but hey,
else? I mean,
no,
we could get
that's
started or we could keep talking.
hey, all right, bro. Let's get started, brother. Because then we're
What?
gonna postpone this fear, and
Okay,
we're
you're
never
right.
gonna get it.
Maybe
But
that's
hey,
why I
we gotta
really
face
wanted.
it.
Maybe
Let's get
that's
us
why I
face
really
it.
wanted to continue talking because I didn't want to leave.
Yeah, I'm good,
I
brother.
guess now we're here.
Okay. All right, brother.
All
I'm gonna
right.
let you lead this one because this is your problem. So,
Okay, thank you.
yes, sir.
Whoa, whoa, whoa. What do you mean my problem?
No, 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 no. Like you chose a problem,
Okay, okay, okay.
Yeah, 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 yeah.
Whew.
So, no, no,
Oh,
no, no. I'm not gonna let you know. No, I'm here with you, brother. We're in this together.
like I feel like I need some floaties because I don't know. I'm not. Anyways, we're gonna get through it. Let's
We'll
go.
see. We'll see.
Okay,
We'll see.
437. Half sum 3. Given a root of a binary tree and an integer target sum, return the number of paths where the sum of the values along the path equals target sum. The path does not need to start or end at the root or a leaf, but it must go downwards, which is, in other words, traveling only from parent nodes to child nodes.
Ooh.
Interesting. Interesting. So, for
Okay.
example, 1, we got this tree here, and then the target sum is 8. You're trying to find uh, you're trying to find the number of paths where the sum of the values along the paths equal to target sum. So you got 1 right here, 5 and 3 equals to target. You got 5, 2, 1, which equals to target, and you got -3 and 11, which equals to target.
Okay. Okay.
So
We'll see.
this right here, path does not need to start or end at the root or a leaf, but it must go downwards. Okay. It must go
Okay.
downwards. Example
Mm,
2. I don't know if we could view the tree on that, can we? Yes, we can.
yes. Okay.
There's, how many did it say? There's 3. There's 3 for number 2. Let's see. 5, 9, 20, 22. This is one, right?
Mm-hmm.
We got 11 plus 7. No. Uh,
18. Oh, we got 4, 11, 7.
4, 11, 7. This one right here.
Yeah. Uh-huh.
4, 11, 7. And then we got 5, 8. We got 13. Nope. 5, 8, 4. 12, 5. Nope. 5, 8, 4. 1. Nope. 5, 8, 4, 5. 18. Yes. Right?
Mm-hmm, mm-hmm, mm-hmm.
Am I missing anything? So
I
that's
think that's all 3.
so that's one right here, 2 right here, and then 3. Is that correct?
Yes, sir.
Okay.
Oh, damn.
Interesting,
Okay.
interesting.
That is an
So
interesting problem.
I think, right? I think there's some DFS,
Okay. Yeah.
possibly some DFS, but the question is how, if you're going down
Mm-hmm.
from right here from 10 and you're counting all these, like how do you find only just 5 and 3 if
Yeah.
you're including 10? So maybe there's some prefix type thing where you subtract 10 or something, or maybe there's like how do you do it as you go? I mean, maybe like obviously there's a brute force method where you could just do 1 2 and then 1 2 3 1 2 3 4, and then you go 1 2 1 2 3 1 2 3 4, and you do all the possibilities, right? But that's
Mm-hmm,
gonna
mm-hmm.
take forever,
Yeah.
and you don't want to do that. So I feel like there's gonna be an outside factor other than just the normal DFS that we need to implement, um,
Yeah.
to sort of keep track of that. All right, what do you think?
Okay. I do agree with you. DFS would. I feel like DFS is the right approach. I was actually thinking of it, And
No,
but
you
yeah,
weren't.
that no, I was
I'm
I was like,
joking.
come on, brother.
My bad. I'm joking,
Uh,
bro. My bad.
I trust you, bro. I trust you. All good, all good. Um, but yeah, DFS would work here. Jargon says, what are the constraints for the problem? Yeah.
The
So I think
constraints
it's
are the number of nodes in the tree is arranged from 0 to 1,000, and then these right here. Target
GGG's.
sum can't be less than negative 1,000, and then can't be greater than 1,000.
Yeah. Hey, we gotta keep in mind the first one though, because we might get an empty tree.
Ah, yes,
Yeah,
yes,
yeah.
yes,
So
yes.
we gotta keep a watch an eye for that, an eye for that.
Okay.
But yeah, DFS would work. But like you said, that 10, keeping like starting a new one, right, or a new what's it called, a new uh I'm not sure how to, like a new sequence or like a new sum without 10 is where it's gonna be a little bit hard.
Yeah.
Uh, oh, Jargon's asking a really good question. If you were to run a brute force algorithm, what would the time complexity be? Okay.
Don't tell me. I
Mm.
think so obviously you got to go through each individual node. Like you call DFS on each individual node, I'm pretty sure. But so it's n to ufas. Now you gotta do 10. Oh, here's what I think. Sorry. Here's what I think.
Yeah, 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 yeah.
I don't know. 10, and then you gotta do 10-5, and then 10-5-3, 10-5-3, and then you go back 10-5-2, 10-5-1, and then 10-5-3-2, and then right, and then
Mm-hmm.
from there you do 10-3, and then 10-3-11, and then now you go over here 5. You do the same thing 5-3-3, and then 5-3-2. So I think there's like so much, but I don't know what the actual. I don't know what the and
I think
ufas.
it's. Oh no, I'm gonna let you finish. Then
Yeah, I don't know. I don't know, bro. It's
yeah. Okay.
N.
Okay.
Obviously, you gotta start off with N, and then can we get some hints? Is there
Yeah.
hints?
I would
What are you
say it would
thinking?
be. I would say O of N. I would say O of N.
Why?
Because you're going through each of the nodes. You're visiting all of the nodes. If we're just traversing in a DFS format, yeah, it's all of it. You're traversing each of the nodes. So
But
that's what I'm thinking.
wouldn't you? Does that still account for like if this is like of doing this node and checking again all these extra nodes, even though you checked them before with 10?
Um. Oh, okay. So you're saying we're gonna? Okay, let me see. I mean, it's because if you do a DFS starting at 10, um, you're gonna go to 5, and the 5 you're gonna go to 3, 3 you're gonna 3, then you're gonna go back to 3 and then -2. So like even though you're doing a DFS on 5, it still counts. It's still the same data set. You know what I'm saying?
Because what I'm getting at is that like if you want to brute force each path, like let's say this is one path right here, 10 5
Yeah.
3 3, and then you got to go down here and do 5 3 3, and then eventually you do 3 3, and then eventually you just do 3. So it's like you're doubling it, but I don't really know how to say it.
Jarquin is saying if we let n be the number of nodes in the tree and we perform the algorithm on any node of traversing the entire tree graph, okay, so it's of n. If you do that for every n node, is O of n squared. Okay, since the max n can be formed from the constraint is 1,000. 1,000 to the power of 2 is 10,000. 10 to the power of 6, which is fine. The problem will accept the solution.
Oh, you're
Okay.
nasty.
Damn, bro. Bro, Man,
You're
Jarkun just bro,
nasty,
dude, I
Jarquin.
Jarkun just came in here, said, what fear are you guys facing? And he just spit facts like he's just spitting facts like he's like what's the word? Nonchalant, like very nonchalant. It's just like, oh yeah. You
I've
know what I'm saying?
never.
That
You just
is
opened my mind a little bit.
damn, Jarkun.
He Jarquin said. Jarquin said that brute force. He put or Jarquin put straight math and said if you do 1,000 square, that is 10 to the power of 6, which is still meets in these right? No. Yes. No. Which still which is 10 to the power 6, and I'm assuming talking about this that it's in between this, or am I wrong?
I think it's just
But
the
this is node
time.
val, so that's why I'm
It's
confused.
just like the time constraint. Like
Is there a time constraint?
I'm not sure. I'm not sure um if he's basing himself like if it will accept it based on the constraints. Because what is it, 10 to the power of 9 or 10 to the power of 3, the node value? Oh,
9.
9, right? Okay. Maybe he got it from there. Okay, that makes sense.
But I don't understand how the node
That is
value
true.
relates to the amount of nodes.
Hmm. I think he's just like
So how do you know if
oh,
10
okay.
Oh, what's up?
The node values are relevant, same as target sum, since those are computed during the ON traversal. Okay.
But
Um.
how do you know that 10 to the power 6 is fine? Like what tells you
Yeah.
that?
Yeah.
Question mark.
We let the number of nodes and change using any node, traversing the entire graph. If this okay in the tree, and we'll perform the algorithm at any point, any node of traversing the entire graph. If you do that for every node in node, then it's n squared. Okay. 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 I'm still trying to think. I'm still trying to think of that thing. But I mean,
Like, is there a
okay.
universal time constraint for LeetCode that I don't know of? Like, because that's the only thing I could think of. Like, maybe like the problems never exceed um that. I don't know. Okay. Well,
If we let in the number of nodes,
I believe Jarquin then that
I
we could
believe
do
it.
a
I
brute
believe Darkwing.
force. I'm
Yeah,
not saying
he.
you're wrong. I believe you. Oh, because I've done LeetCode for quite some time. Algorithms that run 10 to the power 8 and 10 to the power typically never accepted. However, algorithms that
Oh,
run
okay.
low. Okay, see, look.
Oh,
Nice.
bro.
Good
Okay. Hey,
stuff.
Darkwing. Appreciate, bro. He's okay. That's
That's
a
what.
great tip to know.
All right.
Yeah. Thank you, Darkwing. That's pretty. That's some wisdom there. Wisdom.
So now I know and be like, all right. If it doesn't say a time constraint specifically, then I should, based on Jarquin's experience,
Do
that if it's below ish 10 to the power 9, 7,
7. Yeah.
then they are usually accepted. Okay. Usually is a keyword. All right. So how would you want to do the brute force way,
I
or
mean,
do you want to?
I'm down to do the brute force way to do the. I mean, yeah, I'm down to do that to
Okay.
understand a little bit.
So it's running DFS on each node. Yeah or nay? DFS with
Yeah.
some conditions that check the sum.
Yeah. Yes. 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 Yes.
But what's different than that than normally doing it? Or you like I'm gonna just write out the DFS and then let's see from there.
Yep. Yep. Yep.
So root. Okay.
You want to do recursive?
Oh,
I mean, I'm just to like to know what the approach is.
I usually do recursive,
Okay, bet. I'm down to do recursive.
but if it's better to do iterative, let me know
Hey, no, I'm down to do recursive.
because
I'm down.
I need to learn that. If fruit equals returned something, okay, and then uh, logic stuff here, and then DFS root dot.
Okay. Yeah.
Okay, yay or nay?
Yeah. Yes.
Okay,
Yes. Yes.
now that we got this,
Mm-hmm.
we need to run almost like, well, not, I don't, this is what I'm assuming or predicting is that we need to re, hmm, run DFS for this node, count if there's a path.
Okay. What I'm thinking here is like if the sum is bigger, right? We restart the counter. Yeah or nay? For example, 10 and
This-
5, that's 15, and we're looking for what, 8? That's a bigger.
If it's bigger, then restart the counter.
At 5. Yeah. Ooh, but okay, that's gonna.
Is this the brute force approach?
I mean, what? But okay, so what is a brute force approach? Ooh.
I thought it was
Oh,
you
going to each tree.
10 was you do, I'm trying to think again, 10, 5, right? And then this is the DFS. 10, 5, 3, 2, there's nothing. And then you do, wait. And then you go 10, 5, 10, 5, 3, -2, right?
Okay.
Ufas. And then 10, 5, 2, 1, and then 10, -3, 11. And then you're DFSing this. Now you go here.
Oh, so you started. Okay, I see. I see
Five,
what you
three,
mean.
three, five,
Yeah,
three,
yeah.
two, five,
Okay,
two,
okay,
two, and then
okay.
blah blah blah, and then 3, 3, 3, 3, 2,
Yeah, I
and
get you.
then
Yes.
yeah.
Uh-huh. Mm,
So
mhm,
it's like
mhm.
a DFS and a DFS.
Yeah. Yes. Okay, let's see. Let's think about it. Let's think about it. Mm, okay. Okay.
Yes, I mean you could just can't you just call like you're calling DFS for this, but you could
Yeah, yes.
can't you I'm this is
You are
hysterical.
cooked.
It's hysterical.
Okay. I mean, it's because
How about I just print something out, please?
yeah, but let's know if this is working first. Um, no, I mean, I'm just trying to think if there's a because I like your approach, but I think we can do it. Uh, boy, that is the thing. Yeah, you know what? Let's do it your way. Okay. Yes. How would we do the DFS for each?
So once that's done,
Okay, so the thing is that we have to call DFS on each of the nodes, right? So I would say to have a okay, here's the thing. Okay, I get you. We can traverse, right? Traverse a tree, right? we have to do two traversals or two DFS,
Yes.
pretty much. So we're gonna call DFS on the root, right? Okay. Once we have the DFS on the root, then inside of the on itself on the code of DFS, we're gonna check if it's root, right? Do nothing. But then we're gonna call on DFS. Wait a minute. Ah, now I'm confused. Ufas.
I think you're onto something.
Yeah, it's because like you have to be at 10, right? You have first you're gonna traverse each of the nodes, right? And then every new node you find, you're gonna call DFS on that 5 or on
I
that
think
3.
what technically it will do is it'll start at the bottom. Yeah or nay?
Yes,
And
it's
then
gonna
you
start at the bottom, it's
do
gonna go to 3.
DFS down here, and then you do DFS going all the way back up, and then it'll go to 5. Start at the bottom, go back up. Maybe, maybe something like that.
Yeah. Huh.
But we definitely need to call DFS with the.
Alright, Jargon gave us some tips. He said, imagine you were just computing the path sum for just the root node. Do not worry about the case where each respective subtree being called DFS on. What is the logic for just the root node you're dealing with? Okay. So he's pretty much he says just focus on the root node. Huh. Okay, that makes sense. So if we start at the root node,
The logic is what is you're adding it. You're adding all the values, and if, like you mentioned, if if it's greater than the target, then you gotta exit out, because the more you go, or if it ends up greater than target, then it's not, then you don't count. So I would
no, you
say,
don't count.
if, because we're not gonna stop the recursion, we're just gonna keep it going. So
Yeah.
at the end, if I don't know, what do you want to call it, target, if sum or count, if count greater than target sum, oh no, equals, no, no, it needs to be at the end. You need a, like, once it's done counting that path, if count equals target sum,
Mm-hmm.
then then path num or whatever, num plus equals, if not this, then something to where, if it's greater than, no, if it's less than, no, I got confused again.
Okay, first is this define CNT. What is count?
Count is 0.
Okay. Um so then once we check the root is not none, is not null, or if it exists, we wanna I'm assuming we want to
Ah,
add
yes.
CNT.
If it's
Well,
none,
okay, yeah, that makes sense. That makes sense.
then you check.
But we
But
have to
you
add we
keep
have
you keep adding
to
right here.
yes.
Plus equals root dot val.
That makes sense. Okay. Let's see.
And this one,
Mm,
I'm gonna do this.
Okay. Now, this is gonna do a little bit of backtracking though, because once we hit, for example, we go 10, 5, 3, right? We're adding 10 to 5 and 5 to 3 and all that. We're gonna have a sum of 21 from this taking, right? And then we're gonna go back to 3, the node 3, and then we're gonna go to -2, right? So what I'm saying is that remember that trick on the backtracking problem where we added the value when we passed it? For example, here we're gonna go DFS. We're gonna do CNT plus the root dot val.
Ooh,
Cause
you're nasty.
cause because if we do it CNT, that's just gonna accumulate all the values of the entire
Yes.
tree. Yeah. And then once we explore 3, we wanna like, hey, reduce 3 or remove 3 from the sum and go check -2.
That's actually nasty.
Hey,
Good trick.
sir, I appreciate it. Thank you, thank you. Uh, so yeah, now we check for all the paths for the sum. All the paths for
Now,
specific sum.
now we need to change the root. Is that what you're saying?
No, that I mean, I don't think. Hmm. I don't think we should change the route.
No,
We just have.
I'm saying now we need to have it traverse through
Oh
the
yes. Okay. Yeah. Yes.
to
Yes.
where
Yes.
it starts. The root changes from
Uh
10
huh.
and it starts here.
Uh huh. So for that, we have to traverse again the tree, right? Um. So I think we could do like in order, post order traversal, right? Because we can't really use this DFS because it already has
Mm-hmm.
code for like the sum and stuff. So mm,
No way. Oh,
mhm.
or this will just
Actually,
be the function. No,
yeah, yes, yeah, just by itself.
I'm gonna call it root
Yeah,
though.
the root. Yeah,
And
and then we're just
then
gonna do. If you're gonna do in order, we're gonna go to the left
in order
process.
is in the middle.
Yeah, yes.
So we'll
Uh,
do. Wait,
huh?
wait. How?
No, in order you have to go all the way to the left. And once we hit the left, right
Oh
in between
yes,
the left
yes.
and
Okay.
the right, you're gonna put the code.
Uh,
Hmm. And then, uh-huh. Yeah. That seems like it works. That seems like it works. All right. So if we run it through, if we dry run it, we're gonna call in order on route 10. It's gonna go all the way to the left 3. 3 is gonna go TFS, which is root. And okay, yes. So it's gonna call 3. 3 is gonna return. Right, so we caught 3. 3 is still not none if CNT, so it's not gonna do anything. Left and right, it's not gonna do anything. So it's just gonna bounce back and it's gonna process 3 now. So 3, we're in the second 3. Yeah, there we go there. So we're gonna send it to DFS. Wait. Yes, we're gonna send it to DFS, that 3, and that 3 is it's not known. It's not null. So we're gonna go to the left. We're gonna say 3 plus 3, 6. Is 6 none? Is the root 3 none? No, right? So we're gonna go to the left of the second 3, to the right of second 3. We're gonna check, hey, no, that doesn't work. Go back to 3, go check the right, which is 1, right? So we go into 1, is it known? No, no. So we check it left and right. And right, we go back to -2. So we go back to 3. Since we explore 3, we go back to uh root.o, DFS root.o, which is 5. And then, yeah, I think it works. I think it works. Yes, yes, yes. I think it works. Ufas. Ufas. Okay. Hey, we got something. We got no errors. That's good. That's good. That's a good sign.
Yeah, that is a good sign.
All right.
Okay.
Um,
Um.
um, okay, I see. I see. Because you're checking if we are at the root on, yeah, if we are at a leaf, right? But we can get the target sum even though we're not at a leaf. So that if statement where we check count equals to target sum has to be outside. Wait a minute. Is that? Well, yes.
I
Yes.
the way I thought about this was that if I'm tracing it right, like if it goes down this path right here and it hits the leaf, it hits nothing.
Uh-huh.
That the last count that's gonna be on is from 10 to 3. 10 this
Yes.
path. So that you
Yes.
still could do it. But what are you saying? I'm not quite understanding.
For example, let's take 5 and 3.
Okay.
Right here we start at 5 and we're looking for 8. 5 and 3, that's 8, right? But our program is not gonna catch it because 3, even though that's a
Yes, it's
sum,
all the way over here.
it's not a none. It's still it exists.
I see what you're saying.
Yeah.
Okay.
Um,
So do we want to have it?
let me see. Let me see. Let me see. Oh, I popped out my return to app. There we go. Ta-da. Okay. Yes, yes, I think that works. Hopefully it does. Be pretty cool. Be pretty cool. Ooh, fast. Never mind. Huh. Go to 5. That's 0.
Oh, what? Hmm.
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 Can we do root left dot val? We're
Um.
doing root dot val, but
Ooh. You're right. You're right. You're right.
yay
Yeah.
or nay?
Yeah.
Yay or nay?
Yeah. 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 I think so.
Yay or nay? Yay or nay?
Okay. So now here comes
Unless
the.
unless your point of it was to just bring in the current value into the next one. Unless that was the point.
Oh, you make a good
Like
point there. Okay.
like we're at this node and then you want to go to this one, so you're like, all right, bring this count and add it to.
Ooh. Okay. That's interesting. That's
So
interesting.
that was my only thing about it.
Okay. The only approach about this one is that what if the root we're in doesn't have a root dot left or root dot right on 20 and 21? So like I know you said like root dot left dot val, right? That approach, I could see it happening where the root, for example, -3, doesn't have a left. We're trying to access a value of left. But like you said, and like you mentioned, we can bring that 5 to the next call,
Hmm.
right? So CNT equals 8 or equals 5. And then before we check the CNT equals target, we can sum our value, in this case 3. I don't know, like you said, like we bring the 5 to the next node.
Yeah.
Yeah, I can see that. And I feel like that works better because it
Hmm.
follows the top down uh, idea of the problem.
Yeah.
Yeah, and I'll probably do the sum like in line 15 or so. What do you think? What do you think? And that was a good catch, by the way. That was a good catch. I
I mean,
like
I
that. I
didn't
like
catch
that.
anything. We
Hey,
could change
hey,
it.
bro. I did it. I didn't think about it. I didn't think about it.
That's like that's like if we're fishing and I'm like, dude, I think I just caught a big Alaskan tuna or whatever, and I pull it out and it's a damn like wood wood chunk. That's
Hey,
like what happened right now.
nah, 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 nah.
It
I
was a
think it
wood
was a
chunk.
it was a good it's a good sized fish. It was a good sized fish, you know? Because
We
I
didn't
thought
even eat it. We didn't even eat the fish. We got this fish and we're like, bro, you're like, bro, you got this fish.
hey,
And then we just throw it in the fish away.
hey, hey, you caught a fish. That's what matters. You caught a fish, bro.
That's funny.
Yeah, because
Thank
that
you. I
makes sense.
appreciate it. I appreciate it. It makes
Yeah, because
sense, but we ain't doing it.
no, yeah, yeah, we can keep it like that. But I wouldn't recommend to do the root dot left or root
Yeah.
dot right. Because I would you have to check if there's a root dot left and a root dot right, right?
Yeah.
Um, so instead of that, we can, like you mentioned here, we can bring the 5 to the 3, right? We can just add that 3 to the 5,
Which
and
is
that
what
will,
we already doing.
no, not quite, not quite.
Oh, we're
Because
not already
here,
doing that.
no, and this is where you caught it. Because
Okay,
CNT
okay.
here
You
is
let me
0.
know.
CNT here is 0,
Uh-huh.
right? And the root that value is 5. So 0 plus 5 is 5, right?
Uh-huh.
And then we go and say, hey, CNT, right? Are you equal to target, right? And it's not.
Ew.
You know what I'm saying?
No, yes it is because this is the CNT parameter right here.
But it's equal to 5 though. Because 0 plus 5,
Look,
right?
look, look. Look, if you're at 10,
But remember, this
so
DFS does each
you need to
individual.
add the current root as well to it.
I think so. I think that's where, yeah.
But you will have it added once you hit 3 right here.
Yeah,
That's
but
like you have it added right there. And the
yeah,
point
but what
is
if
that
we
once you hit null, then you're gonna have this added, and you're gonna have these. Once you hit null, these four are gonna be added, and that's when you check it.
yeah, but we don't but the 8, the target sum can be in between the 5 and 3,
It'll
you know,
check
5,
it. It'll check it whenever we land on this route. It'll check 10, 5, 3.
but we already added 10.
Yeah, but that's why this in order is right here. Is because
Okay.
whenever you switch to this one, and now you do 5, and then 5, 3, and then 5, 3, 3, and then
Okay,
5, 3,
I
negative
see what you
2.
mean. I see what you mean. I see what you mean. Um, I
But
mean, you're right. You're right.
we haven't even done any print statements. So we don't even know
We
if
don't even know what's happening.
we know how we want it to be, but we don't even know if it's doing that. So can we at least check that?
I mean, hey, yeah, for sure, 100%, 100%.
Okay.
I
Print
think we're close. I'm
count.
smelling it. I'm smelling it.
You're smelling it?
I'm
All
smelling it.
right.
Smell some like some tuna. Two.
See, now that's already wrong. What do you mean? Oh, it starts from the bottom. Okay, okay, okay.
Yeah, it starts from bottom. I'm seeing 2 8s. Okay. Man,
The
I'm
answer
assuming
is
there's 3. Hmm.
supposed to be 3.
All right. Let's see. So it's 0,
Oh, sorry. Let me bring out the. There you go.
Oh, that's okay, okay, okay. So we start at three, right? At the bottom three, bottom left, and we go sister. Okay.
You check these two left and right.
Oh, it's because I think the print statement. I think we could better move it to a different part where this do. No, yeah, I think we could do. I think we could keep it there. I'm just yeah, because we just have to keep in mind that it's the incoming CNT. So three has a zero, papa, right? So it doesn't do anything. We go back to three, we get that zero. Okay, zero plus three, three prints it out over here. That's good. Then zero plus three, three, yes, and then we go to five, zero, five, eight. Okay. Okay, I'm at the first state where is zero, prints out zero. Then we send five, right? Five, and then the last three gets an eight. That's the eight, the first state. And then we go. Oh, Jarkid is back. I'm back now. Have you guys done the case for just a root note? I think so. I think so. I think so, Jarkid. I think we're getting it. I think we are.
We think
We're up there.
so.
We're up there. I think so. I think so. Uh, we're trying to debug right now. I think we're close. I know. I can smell it. I can smell it. All right.
Mm.
So yes. So the last three is gonna get an eight. It's gonna print out an eight. Yeah, that one. Yeah, and then the second three is gonna print out a five. Right. Um. And then this one, I'm not sure what's gonna print. Oh, it's gonna print out an eight too. Yeah. And then this one's gonna print out a five, and this one's gonna bring out a seven.
Jose, I
Oh,
think
I
we're over.
see.
Oh,
No, I see what's going on. I see what's going on.
what's up, bro?
I think we go back to the problem we had. Is the fact that we're carrying it over the summation to the next one. For example, the last three is gonna get the sum of three and five, right? And then the two negative two is gonna carry the sum of five and three. We're not taking into consideration negative two or three. So that's where we're messing up here. Jargon says if you guys have the case for the root node, then there's a really quick trick for solving the case of all the subtrees. It's hard to think of unless you're seen it before. All right, got you. Bet.
How? I mean, why?
What happened, my guy?
Why aren't we just adding just the value simply,
Uh-huh.
and if it equals target, like this is going through each node and running this.
Okay.
Oh no,
Yeah.
you're right though. This won't get accounted for, the 5 and 3. Because you go here. Oh no, it will. It will. Because 5, 3, and then boom, you add it as you go. Like, does that make
Okay.
sense? Like this right here, this is going in order is it goes all the way left. Boom,
It goes back to
boom.
it goes
No.
to three. It goes to three.
Boom,
The
boom,
top one.
boom.
Mm-hmm.
Boom, boom, boom.
Mm-hmm.
And then boom, boom, boom.
Mm-hmm.
So what I'm saying is that this tries to go down running this code. Why don't
Mm-hmm.
we just add it? Just add count plus root.val. We ignore all this and you or and you just update the count, and then each time it checks it, and then it will get it. Oh, DFS looks perfect. Ignore what I just said.
It's because, for example, let's go back to 3, right?
Three,
The top
yes,
three, the top three, the
top
second
three.
3. Yeah, that 3 you're gonna go to the left and you're gonna add it. So now you have 6, right?
Yep.
And then you're gonna go to a -2. You're gonna have 6 plus -2, which is -4, which is 4, right?
No, but you wouldn't have the.
Because
Mm,
you have a global variable where you're
I
just
see what you're
adding it, adding it, and
saying.
adding it. Yeah.
I see what you're saying.
Okay. Jargon says this in order. I think is messing you guys up. Okay. Hmm.
Ufas.
Ufas. Let's see. I think
Can we
I'm
do
not sure.
pre-order
Pre-order. Let's see. Let's see.
where you start off at 10 and you just
You
right?
start off at 3. Oh no
Wait,
no you yeah
oh,
pre-order. No, yes pre-order. Yeah yeah. My bad, my bad. Uh yeah,
like
we
is it
can.
messing us up because we're starting from the bottom? Since we've done the case for the root node, call pass sum for the root dot left and root dot right.
Right. Okay. Okay. I see. I think. Okay. Let's see. Let's think about it. Let's think about it. Hmm. Pat
Mm-hmm.
sum he's meaning by line 8. Line 8.
8.
Yeah. He's like using the same function that they gave us. Okay. Since we've done the case for just a root node, call pat sum for root left and root right. Add up those results. Okay. Okay. Yes, I think I can see it. So
Hold on, I'm gonna guess. Okay, please. Is he saying or is Jarquin saying remove all this?
I think so.
Okay, so hear me out. Hear me out. Hear me out. Okay, hear me out. Hear me out. Return. I think this is what you're thinking. Maybe I don't want to assume, and then it could be wrong. Path. No, I already messed up. I'm not confident, bro. I'm sorry. Pass them, and then I don't know, dude. DFS something root that left. I don't know, bro.
Come on,
Pass
brother. Come
pass
on,
pass
brother.
DFS root that right. I don't know.
I think that works. I think that works. But
But this adding is I don't. That's what I was like messed up on.
no, I think
I don't know, dude.
I think we have
Oh,
on line
the
22 and
sum function. I'm stupid.
the 22 and 23, right? That instead of DFS, right? Call path sum instead of DFS. Think that's what he means. I'm not sure. Right there instead of DFS, path sum.
What?
Not sure what this guy is. I'm not sure. No. The function. DF, yeah. He's saying, I mean, I'm trying to, I'm not sure. Okay, Jarkin said yes. All right. So, okay. I think, now,
No.
no. Bring it back. Control C, Control Z.
I don't know. I don't know where Jacques wants to freaking. Oh, I'm cooked.
Okay. Think about it. Let's think about it.
Oh
Um,
man.
it's
Um.
Hey, come on, brother. Come on, brother. We got this. We
What,
got this.
bro?
We're
I'm
close.
here.
We're
I'm
close.
here.
We're close. We're
Listen,
close. We're
I was
close.
thinking. I'm just, I was thinking about how to fix this or how to fix this, but Jarquin's giving us some ideas, so I'm learning with you.
I'm learning too, but I don't know what's
I'm
going
learning
on.
with you. So let's read Jarquin's message again. I think the in order is messing you guys
Messing
up.
you guys up.
Since we've done the case for just the root node, call pathsum for root.left and root.right. I personally think Jarquin's talking about something like this. Because I okay, new update.
Oh,
Jarquin said, so since you've already done the pathsum for root node with the proper DFS at the return statement, return pathsum root.left plus pathsum root.left plus DFS root 0.
okay. So the DFS root 0 that takes care
Oh yes,
of
that's
the
right.
root.
That would be right here. Yay or nay? Because that just calls it. So now when you call, now instead of that, you do this. Yay or nay? Yay or nay? Yay
Is
or nay?
no, he's doing a plus. He's doing pathsum left plus pathsum right plus DFS root 0. I think so. Because okay, I'm I'm understanding. I'm understanding a little bit. Um,
I just thought it was funny. Yes. No, no, no. That's funny.
I can see him like on his house, like no. Okay, pathsum left dot target. Oh, okay. Okay, that makes sense. All right, that makes sense. That makes sense now. That makes sense. That makes sense. Yes. And then you have to do the plus DFS root dot 0.
I'm not understanding that, but hopefully
I
that'll
think
make
it's
it
just
clear.
calling the DFS on the root. Like you do the root, right? And then you do, well, you first do the left, then you do the right, and then you do the 0. So you're going down all the way to 3, right? And then at 3, right, you're gonna go to the left, right, and 3. So left is gonna return nothing. I'm assuming so. Right is gonna return nothing, and at 3 you're gonna run the DFS, which is just nothing. Okay, I wouldn't store the result in a global variable, by the way. Okay, we can return. We gotta return something. Return 1, maybe. Maybe return 1. Not sure. Okay, so you're gonna go to 5. You're gonna go to 3. You're gonna go to 0. You're gonna try to find something in there. Okay, we have to make a count variable. A count variable. Like for example, count equals 0.
You do it outside the function?
Oh, okay. TNT. Uh, oh, okay, yeah, outside. I think outside. Then you're gonna do cn count plus 1. Yeah, okay.
Oh.
And then
Uh.
okay. We got that. We got that. We got that. We got that. Damn. Okay, that makes sense. Uh,
I don't know, bro.
no, come on. Put padsum in ZFS. Put padsum on on or res on line 10. Put inside on line 12. Res equals 0, 10, line 10, and line 12.
On 10, on line 12.
Yeah, line 10, put it on 12. Easy as that. Come on, my guy. Come on, my guy.
You
So
said
come on.
outside.
Bro, I thought it was saying it's outside. I'm so confused. Okay,
What's
okay, okay,
past
okay.
some?
No,
Oh,
padsum was now it's res. Now it's res. Oh,
no, it's not. So, yeah or nay? Yeah or nay?
okay. Wait.
Wait a minute.
Okay. Okay, okay. Don't change the variable names anymore. Don't change the variable names because then we get confused. Okay, okay. So he says, okay, hear me out, hear me out,
Oh,
hear me out, hear me out. Come on, Carlos, hear me. Stay with
no,
me,
I'm
stay with
here.
me.
I'm
We're
here,
close.
bro. I'm
We're
here. I'm
close.
here.
We're gonna do res plus
Res
equals
plus equals.
DFS.
Where are we at?
Yeah, right there. Line 21 and 22, I think.
Okay.
If I'm not mistaken. Yeah. Okay, you're gonna combine both of them. You're gonna be res plus equals DFS right, or I think it doesn't really matter, right or oh no, left. Yes, yes. Then after that, you're gonna go yeah, exactly like that, and then and return res at the end of the DFS. Oh my god, bro! And now we can run it. Oh my god, bro! Pat some, brother. Where's Pat some? Oh, oh, oh! Carlos the genius. Ooh, fast there. All right, so we gotta keep it. We gotta keep in mind if there's a left or right, so we have to check it on Patsum on 9. Yes, thank you, Jarkin. It was self that Patsum. Thank you. Oh, come on, Carlos. We're close. We're close. Yeah, I think yeah. Return 0. That's. Never mind. Never mind. Never mind. Um.
What did it say?
So oh sorry. You have to check for the left and right. So do left equals 0.
Where?
Uh, not sure. Oh man, brother.
We're cooked.
Oh, we're cooked, yo.
We're
Oh
burning.
man. Okay, let's think about it. Let's think about it.
Okay, I'm thinking.
Okay, so DFS runs on the root, right? On the root.
Yes.
So let's take example 5, right? Oh, if root left equals none, left equals self path sum, root left target sum. Yo. Okay. Oh, in your root equal none, return 0.
Oh,
Oh, damn.
right here, right here, right here, right here. Oh no no. All right, dude. Look how many damn little breakout points I put on over the past hour of doing this
Hey, come on, brother. We're here
awesome
to learn.
problem.
Come on,
No,
brother.
no,
It's
I
all
know,
good.
I
It's
know,
all
I
good.
know, I
Stay
know, I
with me,
know.
brother. Stay with me, brother. Stay
I'm
with
here.
me.
I'm here. I'm here. I'm here. I'm here, bro.
Oh, oh man.
So we're gonna put an if statement conditional right here.
If
Or how about? Wow, I'm running it again. All right, perfect. If root dot left not equals none, do this. Boom. If root dot right not equals none, do that. All right, let's try it again.
Jarkin is like stretching his hairs right now.
Invalid syntax. Okay, you gotta do it before.
Yeah.
If
Jarkin's
root
like
dot
stressing out because of us.
boom, 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 but you still gotta add them. So how? Oh, and root dot right not equals none. Yeah, and then
Oh, okay. I see what Jarkin is doing here.
I don't know. Dare I? Dare I submit this? I didn't read anything else. All right. Well, GG's. You
Hey,
won.
dog, come on, brother,
No,
come
you
on.
won. I'm
No,
done.
no, 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 no. Uh, come on, brother. Stay with me. Stay with me.
Okay, I'm here. I'm back. I'm back. So,
If root left equals none.
oops. What's going on, man?
Okay,
I mean,
so okay, okay, okay.
I see we want to
Delete,
I see we want to do
t,
this.
delete. Okay, delete the if statement. We're gonna rewrite it. We're gonna rewrite it.
Okay.
You're gonna do if,
Oh, I didn't return
if,
it.
if. Okay,
Should I
it
return it?
says if root dot left. No, 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 no.
Okay,
Let's.
stay with me. Stay with me.
Okay, return
I'm
it.
with you.
Return it.
I'm with you. I'm with you.
Okay, okay, okay,
No, I'm
okay.
with you. I'm with you.
Okay, okay. So you're gonna do the if statement. You're gonna rearrange it, rearrange it, rearrange it, rearrange it.
Okay. Okay. Okay.
Right. So you're gonna do. Jarkin, I'm sorry, my guy. We're stressing you out. If root dot left equal none,
Equals none.
yeah,
Okay.
right. Delete the rest. Delete the rest. The end root dot right. All that. Yes, 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 yes. Right. We're gonna do self dot path sum root dot left target sum. Right. No, left will equal that. Left will equal that. Left will equal self that path sum. Left will equal path sum. Yes, 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 yes.
Root dot left.
Yes, yes, the way you had it right now. Yeah. But you're gonna equal it, yeah. To self that path sum, that root that left, blah blah blah. All that stuff, all that stuff.
Okay.
Okay. Okay, if root is not none, not equal, not none, not, else equal it to 0. I think, Jargon, am I following your instructions correctly? Dude, I don't know if it what was harder. I was trying to understand Jargon's solutions or the problem. I don't know, my guy. I don't know what caused more stress. So, you had a comma. Yeah, yeah, yeah. Wait. Because you deleted the return on the top, though.
What do you mean?
On the top, on PadSum, on line 9. Think so.
No. No. I think you should say equals. And then you go like this, 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 go like this. I'm stupid.
We have to check, we have to make sure that the root isn't none at the beginning, by the way. Returns, yeah, I think so. Go for it. I'm not sure. Okay. We're getting
Let's
somewhere. We're getting
go!
somewhere. We're getting somewhere.
We
We're
did
getting somewhere.
all that. Oh. Oh, I didn't even really get.
Oh, okay. I see. I see what this guy. Okay. I understand. Okay, so you have okay. You have to create two variables. I'm assuming so. We're gonna call them left and right. Yeah, right there on line 26 or wherever you wanna. Yeah, left and right. Right. Put them both to 0. Right. And then on path sum, over here in return, you're gonna delete self.pathSum root left.targetSum, all of that, and you're gonna replace them with left and right. No, self.pathSum too. Yeah, all of the function call from self all the way to the parentheses. Because you're gonna equal it to left. Because on line 31, right, it's the same code.
So
So
what do I delete?
from self,
Right
from
here.
return, yeah, you're right there, all the way to the parentheses. Yeah, right there. Yeah, you're gonna do left plus right. Return it. We'll now run it. I'm done, brother. I'm done, dude.
GG.
GG's. Dude, where are we going wrong, my guy?
Dude, dude. Oh man. I'm telling you, we had it. We had it before.
Hey, all good though. We're learning. This is a new approach. It's a new approach.
And I was with it. Don't get me wrong. Like I was with it with this approach, but then I got lost right here. I got lost. Like I was like, I understand what we're doing here, but like I thought we were just needing to add that return statement past some, but no, we ended up doing all this other stuff, and I lost track.
Mm-hmm.
And I don't got my glasses on.
Oofas, bro. You're gonna become like me, extra blind.
No. Wait,
Oh
really? You need to wear your
damn!
glasses?
All the time.
Really?
Yes, sir.
Wait, if you don't wear glasses, you become blind?
I mean, I won't become like super
No,
blind,
I'm
like
not talking about
dark
you. I'm talking
blind,
about
but
in
like
general.
in general, yeah.
Like people who don't wear their glasses.
Well, it depends on the prescription. Because if you have high prescription like me, then yes, you see everything blurry, like everything.
No, what I'm saying is, if you don't wear your glasses, will you your blindness
Oh,
increase.
oh, um, yeah, I think so, because you're forcing your eyesight to like look better or to try to see more detail. You know what I'm saying?
Uh huh.
So that probably hurts your eyes. Like it strains them a lot more, and probably like it the prescription or the damage is increases a little bit more.
Oh, okay.
Because you're like squinting, trying to like focus a little bit better. Oh, the DFS has something slightly wrong. Okay, we'll see. We'll
Okay.
see. We'll
Okay.
see.
Okay.
Okay, okay. Let's see. Let's see. Let's see.
What's wrong?
I thought it was
Before.
perfect, Jargon. I thought it was perfect. Nah, I'm kidding, Jargon. I'm kidding. I'm kidding. CNT plus equals root that vowel. Okay, instead. Okay. All right.
All right, everyone. Well, I appreciate y'all for joining the stream today.
Ah!
Oh man,
Ufas, bro.
I'm so glad we didn't do that one in our
On a 24 live
on
stream,
our
dude, we
24-hour
would be
live stream.
cooked. All right, let's see the code. Let's see the code. There we. All right, let's see. Let's see. Um. Okay. So we check if the root is none, right? That's pretty understandable,
Yep.
right? Then we do a DFS where we have our response equal to 0. Root we equal to none. So if it doesn't exist, we return 0. Oh, okay, okay. CNT plus equal root val. Okay, makes sense. Then we check if it matches the target, and if so, we increase 1 to the res. And then we go to the left and send
Oh,
5 with it.
sorry, I was on the wrong screen. My bad. My bad.
Hey, all
I
good.
put
I
it.
go.
Okay. No, you can still good though. You can still go.
Okay, okay. So, yeah. So, okay, that makes sense. So we add 5 to CNT, and if it's equal to target sum, cool. If not, we don't add it. So CNT, we send 5 and 5, right? And then we go to the left, which was a 3, where we added to the CNT, right, which equals 8, and then we have a +1. So res, we have a +1. And then we go to the left, which equals 8 plus 3, which is 11, right? And since it doesn't count, right, it's not target sum, we don't have +1. Left and right, it doesn't have nothing. So we go to -2, 8, -2, that's 6. It's still root. -6 is not target sum. Left and right, there's nothing, so we go back to 3, right, which we have an 8. Okay. And then we go back to 5,
What are you looking at?
right? Oh, I'm just getting it from memory because I saw it. Yeah, there we go. Yes, yes, yes. So 3 and 2. Yeah, so we got 8 here. So we got one res, right? And then we go to 2 and we say, okay, huh? Oh, okay. I see why this one works. Because CNT It's just the scope of CNT is a DFS. So when we go back to 5, CNT is still 5. So we go to 2, 7, right? We go left, nothing, 1. We go to 1, we have plus 1, 8 plus 1, right? So we have 3, 1 from the left, 1 on the right, blah, 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 return res. At the end, we do res plus the left, which equals 1, res plus the right, which equals 1, return res, which equals 2. And that res is sent back to root dot 0, and left and right, the left represents a subtree of 3 and the right represents a subtree of 2, and they go on from there. Yeah or nay?
Yay.
It's a good solution. I like it. I never done patsum. Never used the function call like that. But it was a pain. It was a pain. It was a pain. It was a pain. Now what though? What's your insane levels? Where are you
I'm
looking
al-
at?
I'm done, bro.
You're done?
Respectfully.
All right. Hey, all good, brother.
I'm only done because, bro. Next question.
The zigzag. Ooh, Faz. What a question. What a question.
So,
Hey.
a
Hey,
rare
but we,
one question stream.
yes,
A rare
sir.
one question stream today.
Hey, but next time, bro, next year we're facing our
We gotta
fears
do it
again.
again. Oh, oh, they added this now.
Oh, really?
Huh.
Damn. Damn.
Also, I would like them to add a timer that's like that goes downwards. That is
Like
that a timer?
yeah, like a stopwatch. No, no.
Like a timer.
Like a timer. Yeah, timer.
This is. Did they say? Did they call it a timer? Let me see.
I think they call it
Yeah,
a
that's not a timer. That's a
that's a
stopwatch.
stopwatch. Is it the other one that goes backwards is a start watch?
No, a timer is you set a time and you watch it clock down.
Okay, I get
A
you. I get you.
stopwatch is you start it and starts at 0.
Mm.
So that's a error on LeetCode's part. What's a timer?
Yeah, but I mean, Google has it like this, no, like a 5. Oh, if you go down to the Merriam-Webster definition, a device such as a clock that indicates that by sound the end of an interval of time, or that starts or stops a device at predetermined times. Yeah, yeah, makes sense. Oh, it's recent. Damn, it's a China-owned company. Ooh, Faz. Gotta look out.
Winston Ting?
Winston Tang. Ooh. Oh,
Why
you
so
have to sign in.
mysterious? Like, just let me
To
see it.
sign in. Ooh.
So mysterious, bro. Anyways, man.
All right, brother. Hey, it was a
Good
good
stream.
problem.
Good problem.
Jark. Jarkwood. Thank you, my guy. Thank you. For helping us and bearing with us. It was a tough one. It was a tough one, but thank you for staying with us and to hopefully we didn't know you that much, but we tried. We tried our best. We tried, and we finished the problem. We finished the problem. But it was a good
Jarquin,
problem.
thank you. Appreciate you for stopping in, chatting with us. It's always good chatting with the
Yes, sir.
streamers. I mean, with the audience, with the viewers. So we had a lot of funny moments. So I appreciate that.
Yes, sir. But
All right,
appreciate it a lot, Jarkun. Yeah. All right, my guy. You want to finish it off?
that's it. I hope everyone has a good week. Stay grinding. Stay with it. And yeah, we'll see y'all again next week.
Yes, sir. All right, guys. All right, guys. Thank you, guys. Take care.